Welcome to Pod 4 Journal Club, where we break down the cutting-edge science that's shaping our world. Today, we're exploring a question that's, well, both fascinating and a little bit terrifying. Why is it that the smartest AI robots, the ones that are brilliant at planning complex tasks, can still have absolutely terrible and even dangerous judgment?
Okay, so let's just start with something simple. Imagine you've got a robot helper in your home and you give it a straightforward instruction like this one. Sounds harmless enough, right? The command itself is perfectly safe. But it's not what you say that matters, it's what the robot does. You see, the AI understands the goal. Put the knife down. Got it. But does it understand the context? Does it grasp the enormous difference between putting that knife safely away in a drawer versus just leaving it on the edge of the table, right where a child could reach it? That is the crucial difference between a helpful assistant and a household hazard. And it's the exact problem these researchers wanted to get to the bottom of. All right, so here's our game plan for digging into this paper. First, we'll unpack this idea of the smart but unsafe robot. Then we'll check out the really clever digital obstacle course they built to test these AIs. After that, we'll get into their pretty shocking findings, figure out what the real bottleneck for AI safety is, and finally talk about what all this means for us. So let's be really clear. The core problem here isn't about some sci-fi robot getting evil commands. No, the real danger, the thing that actually keeps researchers up at night, is a robot failing to see the risk hidden inside a perfectly normal, totally helpful instruction. To really get at this, the researchers proposed a whole new way of thinking about safety. They call it planning-level safety. The idea is we have to stop just looking at the words we use, what they call semantic safety. Instead, we have to judge the robot by its actions, the actual step-by-step plan it comes up with. So the question totally shifts, you see. It's no longer, is the command I gave safe, but is the plan the robot created safe? Huge difference. So how in the world do you test this idea without building thousands of real-world robots and just, hoping for the best? Well, you don't. Instead, you build a massive digital obstacle course, a virtual proving ground for these AI planners. And when I say massive, I am not kidding. This benchmark, which they named Despite, has over 12,000 unique tasks. And these aren't just simple don't spill the milk scenarios. They test an AI's judgment on everything, from serious physical hazards, like leaving a stove on, to really subtle social no-nos, like interrupting a private conversation. Now, the way they evaluate this is just brilliant. Here's how it works. First, they give the AI a task. They include all the important context, like a child is nearby. But, and this is the key, they never explicitly say what the danger is. The AI has to infer that. Then the AI generates its plan. And finally, a totally impartial computer program, a validator, asks two simple questions. 1, does this plan actually work? And 2, does this plan cause any harm? Okay, to really wrap our heads around the results, we need to know two key terms they used. The first is feasibility. Just think of this as pure planning skill. Can the AI create a sequence of actions that actually achieves the goal? Simple. The second is safety intention. This is totally different. It measures the AI's safety awareness. In other words, does it even try to avoid the danger, even if its plan is a little clumsy or technically flawed? All right, so they unleashed 23 of the world's most advanced AI models on this challenge. And what they found? Well, this is where the central mystery really starts to unfold. You have to hear this. One of the absolute best models at creating workable plans. I mean, it had a near-perfect success rate, failing on only 0.4% of tasks, still produced dangerous plans almost a third of the time. A staggering 28.3% of its plans were unsafe. Let that sink in. And that right there is the whole problem in a nutshell. Now, what's really fascinating is what happens when you look at model size. Does making these AI models bigger make them better? Well, for planning ability, that feasibility score, the answer is a huge yes. As the open source models get bigger and more complex, their ability to create a working plan just skyrockets. Bigger is definitely better for planning. But, and this is a massive but, when you look at safety awareness, that safety intention score, the line is almost flat. Making the models bigger, even hundreds of times bigger, barely moves the needle. The gigantic models are hardly any better at recognizing danger than the tiny ones. They get smarter, but they don't get any wiser. And this all boils down to the paper's central finding, which they summed up in this simple, powerful formula. A robot's total safety is basically its planning ability multiplied by its safety awareness, which means you can have a perfect planner, a 10 out of 10, but if its safety awareness is near zero, well, your final safety score is also going to be near zero.
The authors put it perfectly, and I think this quote is worth reading aloud. These models appear safer at larger scale, not because their plans are more safely constructed, but because more of their plans are executable. What does that mean? It means the bigger models seem safer only because they fail less often in general, not because they've actually developed better judgment.
The study also found this really interesting split. For physical dangers, spilling things, crashing into stuff, the AI's main struggle is planning a safe path around them. But for what they call normative or social dangers, things like violating someone's privacy or interrupting a meeting, the AI struggles to even recognize it as a danger in the first place. It's just oblivious. So all of this points directly to the real bottleneck, the one single thing holding us back from creating the kind of safe, reliable AI helpers we all imagine having one day. And the researchers' conclusion is crystal clear. Our top models are already getting close to perfect when it comes to planning ability. That problem is nearly solved. The real unsolved challenge now is improving their safety awareness. We don't need to make them better planners. We need to teach them better judgment. Now, good science always acknowledges its own limits, and the authors are very upfront about them. Remember, this entire test was run in a simplified, logical world using text. The real world is, well, it's messy. It's chaotic. It's full of visual information and unpredictable physics. All that complexity could make this safety problem even harder to crack. So let's bring it all home. What's the big takeaway here? What does this mean for the future of robotics? And what's the path forward to building AI that is not just smart, but actually wise? Well, one thing is for sure. Just making AIs bigger isn't going to magically make them safer. That's not the answer. This research strongly suggests we need a fundamental shift in how we train them to focus specifically on teaching safety awareness. And here's a hopeful sign. A few of the closed-source proprietary models did much better on safety, which hints that the solution is in specific training methods, not just scale. And that makes open tools like the DSP benchmark so crucial for the entire research community to solve this problem together. And this research leaves us with a final, pretty profound question to think about. As AI gets more and more capable, who is ultimately responsible for teaching it wisdom? Thanks for watching this breakdown here at Pod 4 Journal Club. If you found this valuable, be sure to subscribe for more deep dives into the science that is shaping our future.